Hi there, in this video we're going to go over Cramer's rule for solving systems of linear equation. Why do you want to use Cramer's rule? Well, it's especially useful when the coefficient is large or the coefficients are decimals or fractions. I'm going to go over a simple problem to get the concept down, and then we're going to work on a more complicated looking problem where the coefficients are fractions. Let's get started. To use Cramer's rule, your equations need to be in this form. a1x plus b1y equals to c1, the constant. Same with the second equation. To use Cramer's rule, we need to solve the determinant. To get x, we need d of x divided by d. And for y, we need d of y divided by d. So the first thing we're going to do is solve for the determinant, which we label with the variable d. The determinant is going to be a 2 by 2 matrix. And we're going to be using the coefficients from the equations. We're going to use the x coefficients on the first column. We have 1, 3. And we're going to use the y coefficients on the second column. Just remember there's a 1 right next to the y. So y, 1 and negative 2. To get the determinant, we need to take the first number and multiply diagonally. So we have 1 times negative 2. Subtract the second number going to the right and multiply by diagonal. So we have 1 times 3 is equal to negative 2 minus 3, which is equal to negative 5. Here our determinant is equal to negative 5. Now we need to find d of x and d of y. To find d of x, let's reference the determinant where we had the x coefficient over here and the y coefficient over here. If we're finding d of x, what we wanted to do is not use the x coefficient, but replace that with the constant. So we have 12 and negative 9. For the second column, we use the same thing that we used to find the determinant. So it's 1 and negative 2. 1 and negative 2. Once again, we take the first number and multiply diagonally. That's 12 times negative 2 minus 1 times diagonally again. 1 times negative 9. So we have 12 times negative 2 is negative 24. And negative 1 times negative 9 is positive 9. Negative 24 plus 9 is equal to negative 15. So here we have d of x is equal to negative 15. And now the other piece we need is d of y. Once again, we can reference the previous determinant. We're looking for the d of y. We want to disregard the y coefficients. So we're keeping the x coefficients as we did before, 1 and 3. Instead of the y coefficient in the second column, we replace that with the constant. That's 12 and negative 9. To get d of y, we take the first number 1 and multiply diagonally. So 1 times negative 9 minus the second number 12, multiply diagonally, 12 times 3. This is negative 9 minus 36, and we get negative 45. Now that we solve for all the variables, we can plug that in to get x and y. So x is equal to d of x divided by d. Our d of x is negative 15. Our d is negative 5. 2 negative is going to cancel and become positive. We get 15 divided by 5 is 3. And y is going to equal to d of y over d, and that's negative 45 divided by negative 5. And we get 9. Because remember, negative sign is going to cancel. 45 divided by 5 is going to give us 9. So we have our x and y, our order pair solution, 3, 9. And that's our answer over there. Let's take a look at another example. This time, our coefficients are a little trickier. So once again, we're going to find what each of these variables are equal to. Our determinant is going to be, once again, a matrix. Our first column is going to be the x coefficient, and our second column is going to be the y coefficient. So you have 1/2, 2/3, and then 2/3, negative 1 over 5. And once again, remember, we take the first number and multiply diagonally. 1/2 times negative 1/5. And we take our second number, 2/3, multiply diagonally. So 2/3 times 2/3. So minus 2/3 times 2/3. And we get negative 1 over 10 minus 2 times 2 is 4. 3 times 3 is 9. We need to find the lowest common denominator for 10 and 9, and that's 90. 90 divided by 10 is 9. 9 times 1, 9 times negative 1 is negative 9. 90 divided by 9 is 10. 10 times 4, we have 40. So you have negative 9 over 90 minus 40 over 90, and we get negative 49 over 90. And that's our determinant. It's our first variable. Now let's find d of x. If you need help remembering what goes into a column, just remember that when we're looking for x, we want to disregard the x coefficients. And instead, replace that with the constant. So we have 3, 11, 15. And the second column is still going to be the y coefficient. We get 2/3 and negative 1/5. So we take 3, multiply diagonally. So 3 times negative 1/5. Subtracted by, we're going to take our next number and then multiply that diagonally. So we get 2/3 times 11, 15. Here we need to find the lowest common denominator as well. And 5 goes into 45, so our lowest common denominator is going to be 45. 45 divided by 5 is 9. 9 times negative 3 is negative 27. And this one we haven't made any changes. So we get negative 49 over 45. So that's our d of x. To find d of y, I hope by now you remember what to put into these columns. Our first column is going to be our x coefficient. That's 1/2 and 2/3. Our second column, because we're looking for y, we want to disregard that and replace that with our constant, 3, 11 over 15. One half times 11 over 15 is equal to 11 over 30. And here we can cancel the 3 because this is in the numerator, this is in the denominator. So we have minus 2. Now we need to, since we're subtracting, we need to find the lowest common denominator, and that's 30. And just remember, when we have a 2, there's a 1 underneath. 2 divided by 1 is 2. So our lowest common denominator is going to be 30. This term hasn't changed. This will be 60 over 30, because 30 divided by 1 is 30, and then 30 times 2 gives us 60. And 11 minus 60 is going to give us negative 49 over 30. So that's our d of y. Now that we have all the variables figured out, we just plug them into our formula to get x and y. Our x is equal to d of x over d, and that's equal to negative 49 over 45 divided by d, which is negative 49 over 90. When you're dividing by fraction, just remember that you need to take the reciprocal of the denominator and multiply it. So this is equal to negative 49 over 45 times the reciprocal of this, we flip it, so you get 90 over 49. Just remember there's a negative sign here as well. Our two negatives are going to cancel. 49 cancel. 90 divided by 45 is going to give us 2. So our x is equal to 2. And now our y is going to be dy over d. dy is this number, negative 49 over 30, divided by negative 49 over 90. Once again, we're dividing by fractions, so we want to multiply by the reciprocal of the denominator. Our two negative signs are going to cancel and become positive. 49 divided by 49 will cancel. 90 divided by 30 is going to give us 3. So our order pair solution is 2, 3. And that's our solution.